Hi friends, in this video we are going to look at problem 4019. Notice that this is the second of such problem. We also have problem 3853, which is a small size version of this problem. Therefore, the solution here is naturally a solution to problem 3853. Overall, I'm going to first write a longer solution, and then I'm going to give a compact version. So here we are given a string consists of lowercase English letters. So we want to do some merge. So if two characters are close in the sense of the current problem, then we are going to ignore the second one. So here are some constraints. So among all close pairs, choose the pair with the smallest I. This is the one. And if multiple pairs have the same I, choose the one with smallest g. And then after the merge, there will be reindexing, right? So we want to return the resulting string after performing all possible merges. So here are three examples. If you look at the first one, so we have two A's and k is 3. So the difference of the two indices are exactly 3. Therefore, we should ignore the second one. So we will have A, B, C. And in example 2, the first two A's, the second one should be ignored. And then we get A, B, C, A. In this one, we still have two A's, but they are far apart. They are not close. Therefore, we should have the second A. So we have result A, B, C, A, right? So the constraints, so in the first one, so this is the one differentiating with the problem 3853. And the latter has a shorter constraint. So before we do the coding, I want to mention that the key point is that if there is a merge at the index pair ij, then the character si remain unchanged, and the remaining characters are reindexed. So because of this reindexing, so we cannot use the original index or inherited from the original string. Rather, we need to maintain a constant or length of running resulting prefix to correctly computing the cascading merge potentially. So this part actually adds some level of difficulty to the problem. And what simplifies the problem is the first bullet point. So it says that if multiple pairs have the same I, we choose the one with the smallest g. This makes that a linear scan from left to right will be sufficient. So now let's look at the coding. As I mentioned, first I'm going to use the normal order of thoughts or reasoning to write a version, and then we make a compact version. So here I'm going to use a dictionary to track the character and the last thing index. So here is maybe not the original index, right? So also I use a list to hold the character remains. So here you don't need to use stack, you just a list. But here I'm just use this one towards my own habit. So I'm going to use the length to track the indices, which is also the length of the stack. So now the linear scan for character in S. So notice that in this line, I didn't track the index using the enumerate function. The reason is that it's reindexing. So then first, if character not in D, so we haven't seen such characters. So it's by no chance to be close with a previous one. So we need to add this one, stack append character. Because of the add, so we increment the length by 1. So now this is the character we last seen. Its index in the stack will be D character, which is the last one. That is, the index will be length and -1. But if you do this line before this increment of ls, for example, in above, in here, or in here, you just need to write D character equals length, right? So this is the one. Another one is the character is already appeared. So in this case, we need to compute or check if close, right? So the index for the current character will be list, right? Because this is in different block, right? And the previous one was the character, right? So then what we want to check is length minus the character. If this distance is bounded by key, then they are close. So we need to ignore this one. So we just continue, right? Not adding to the stack. Otherwise, so we do the same thing. So we need to add. The reason is that though we see the character again, but they are far apart from the previous one, so we need to keep this one. Then the index will be length minus 1. So once you have this, so you can do the return. Just join the stack. Before we submit, I would like to do a test. Yeah, it passes the 3 test cases. So now let's look at the generic case. Yeah, it passes all the cases. So if you like, you can do something like this. You can do some print, right? So for example, the current index and the current character and the length and the stack status. So this will be something like this. Name I, yeah. So here I didn't track the index, so but you can track to print. But let me just do this one. Yeah, stack. The first example you get ABC, and the second example you get ABC, and the third one you get this one. So this is the one. But if you examine the structure, you see these 3 lines and these 3 lines are identical. Therefore, we can make a compact version. So I'm going to call this one version v1. And then for this one, I'm going to see this. This one. And then this is the case. Or if character inside, then we have a list minus dchar is greater than key, right? So then we do this. And then we just need delete this block. But because if other case, so we just continue. So we just delete this else block. Yeah. So this will be sufficient, right? Now let me test and then run. Yeah. So I would say for easier to digest, you can look at version v1. But for compact version, you can see this version. With that said, I guess that's it for the current video. Thank you for watching.